So what happens if A is not a perfect square? So for example, in the equation 3x squared plus 8x plus 5, you can see that 3 is not a perfect square. So to start just changing this to create a perfect square with our C, it wouldn't work. So how can we change our 3 into a perfect square? Well, I know that if I multiply 3 by itself, I'll then have a perfect squared. But like anything, anytime we multiply one tiny piece of the equation to 3, we have to do it to all parts of the equation. So I'm going to distribute this 3 to give me 9x squared plus 24x plus 15, and then 0 times 3 is still 0. Now that I have my A as a perfect square, I can go about to make C into a perfect square using what we did in the previous examples. So I'm going to begin by taking my 24 and dividing it by 2 times the square root of my A, which is 9. So 24 times 2 times 3, or 24 divided by 6, which equals 4. I'll then square that, and I get 16. So for this to be a true perfect square, my 15 needs to turn into a 16. So that means I need to add 1 to both sides. So simplifying this, I get 9x squared plus 24x plus 16 equals 1. I now can write the left-hand side in factored form. 3x, because the square root of 9 is 3, plus 4, because the square root of 16 is 4, squared equals 1. Just like in all the other examples, I will take the square root of both sides, and I get 3x plus 4 equals 1, and 3x plus 4 equals a negative 1. And now I need to solve for x. And so my solutions to this problem is x equals negative 1 and x equals a negative 5/3. Let's look at another example to make sure that we understand how to do this. So here is our equation for this example. 6x squared plus 19x equals a negative 10. Again, my leading coefficient is not a perfect square, so I'm not going to be able to find C. So to begin, I'm going to multiply everything by 6 because I know 6 times 6 will then be a perfect square. And so when I do this, I get 36x squared plus 114x equals a negative 60. And now I can find my C to make this a true perfect square. So 114 divided by 2 square root of 36. So 114 divided by 12, which this does not divide out evenly, so I'm going to simplify it down to 19 over 2. So my C, if I square that, would be 361 over 4. So putting this into my equation, I get 36x squared plus 114x plus 361 over 4. And then I have to add that 361 to negative 60 to get 121 over 4. I'm now going to write my left-hand side in factor form. So I end up with 6x plus 19 over 2 squared equals 121 over 4. So I'm going to take the square root of both sides, and I get 6x plus 19 over 2 equals a positive 11 over 2, and 6x plus 19 over 2 equals a negative 11 over 2. Now, I don't like to work with fractions once I get to the point where I am solving, and I guess I could have gotten rid of the fractions earlier, but I thought those numbers were already big enough. So I'm going to multiply each piece by 2. So when I do that, I get 12x plus 19 equals 11. And over here, I will do the same thing to get 12x plus 19 equals a negative 11. Now this is much easier for me to work with. So now I'm going to subtract 19 from both sides to get 12x equals a negative 8. And so x is negative 2/3 when I divide by 12. And over here, when I subtract 9, I get 12x equals, 19, not 9, equals negative 30. And when I divide both sides by 12, I get x equals a negative 5/2. And that is my solution to this quadratic. So the only difference from the previous lessons that we've been dealing with, besides for having a leading coefficient greater than 1, is that sometimes they are not perfect squares to begin with, meaning our a's are not perfect squares, and we need to change them into a perfect square.